ladies and gentlemen. Welcome back. Today we are going to be talking a little bit more about atoms. We'll review a little bit from last class and then we'll move into the new material. Just a reminder that you should have downloaded the document that was right above the link that you guys clicked. It reminds you to download it. So anyways, you're going to be taking notes on your computer, so hopefully for some of you that should be easier. But first thing I wanted to do was just review the questions that were at the beginning of last class. You've gotten a grade and it's on PowerSchool already. You have a grade between 60 and 100. If you got a 100, it means you got all 4 questions correct. If you got a 60, it means you got all 4 of them wrong. So, each question was worth 10 points. First question, what part of the atom is the small central core? And the correct answer for that was the nucleus. The next question, what is found moving rapidly around the nucleus? And the answer for that was the electrons. Third question, what part of the atom is represented by a plus? And that would be the proton. And the last question, the nucleus is made up of what 2 particles? And the correct answer there is neutrons and protons. We're going to be talking more about those parts right now, but that was just your quick little reminder about what we did last class so that you have an idea at least what the correct answers were. So, the first thing we have on our new notes, so make sure that you've got both screens open. So the first thing we've got here is element. And this is something that's a bit of a repeat. We've got to keep in mind that an element is simply the simplest pure substance that cannot be broken down into any other substance. We did this one last class, and it's just really important that we think of this is our definition for elements, because we are talking about matter, and when we talk about matter, we know that elements build up all of the things that are in the world around us. So elements, it's really important you know what an element is, because in a little bit, not today, but in a few days from now, we're going to be talking about the periodic table of elements. So it's very important you understand that an element is simply a pure substance that cannot be broken into any other pure substance. So we'll zoom in. Nope, that's the wrong one. Yep, too far. Okay. The simplest pure substance and cannot be broken into any other substance. Reminder, you can press pause, and I'm going to try and do this as short as I can. So press pause, and then you won't feel so rushed. Okay. So, review. We are talking about elements because we're talking about matter. So the next thing is the next natural question that a scientific brain thinks about. Alright, if matter is made up of elements, then what are these elements made up of? And the answer that we talked about last class was atoms. And atoms are just those smallest particles of an element. Those are what all of those models were that you guys drew in your notes last class. Atoms. The smallest particle of an element. So, let's zoom in there. Again, this is a repeat one. So, okay. No, that didn't work. Yes, okay. So atom, the smallest particle of an element. Reminder, please zoom in. Not zoom in. Please pause if you need more time to write this down. Okay, we can now. Yep. Okay. So, we haven't learned anything too new today, so far, but that's going to change right about now. Please, avert your eyes while I get this thing all taped up here. Alright, what you guys have here is a lovely, handy-dandy data table. And data tables are wonderful because they display a lot of information in a very easy way. I mean easy because it's easy to say, hey, this is what we know about a proton, or it's easy to compare between different pieces. Like for us, we're comparing protons, neutrons, and electrons. So it makes it very easy for us to compare those. So the first particle that we talk about is the proton. And the characteristic we're going to talk about first is its charge. And what we mean by its charge is kind of like its electrical charge. Now, just like how numbers can be positive or negative, a charge for a particle can be positive or negative. Actually, it can be neutral too, like 0. So, the charge for a proton, is positive. So that's why we put a plus. The next thing we have is the mass. What we mean by mass, and I'm not going to get too technical here, but mass is something similar to weight. So scientists have created this unit because keep in mind how small an atom is. I mean, it's smaller than cells. Cells probably have trillions of atoms within them. So we're talking about something incredibly small because within those trillions of atoms that make up a single cell, we still have all of those protons and neutrons and electrons. So anyways, the mass of one single proton would be 1 AMU, which is an atomic mass unit. AMU is kind of like grams, only it's, I don't know, it's incredibly many times smaller than a gram. But it's just a unit. That's the way it's like a gram, is because it's a unit. So what we mean by region is where do we find it in the atom? Where do we find it in our model of an atom? So we find the proton, and we should have known this if we remembered the question from last class. We find the protons within the nucleus of the atom. Okay, next one. The next one we have here is the neutron. And the neutron has a 0 for its charge. And just like how I said that charges can be plus, minus, or negative, plus or minus, we also have something, we have a number that is not a plus and is not a minus, and that is a handy-dandy 0. So that's why we have 0 the hero as our charge for the neutron. It has no charge. You'll notice that its mass is the same mass as a proton. It's got 1 AMU. And we find it in the nucleus. So really the only difference that we find between a proton and a nucleus, the proton and a neutron, is in its charge. Okay, the last one, the one that's the most different from the others, is the electron. And the electron is represented with a negative charge. Keep in mind, atoms have an equal number of protons and electrons because they have to be neutral. So if our atom has 7 protons, in order for it to be neutral, it's got 6 pluses here. In order for it to be neutral, it has to have 6 electrons. Okay, so the next thing that we've got here is our electron mass. And you can see here, I know that you see 2,000, but keep in mind this is a fraction. This is saying that an electron is 1/2000th of the mass of a neutron or a proton. That means it would take 2,000 electrons to equal the mass of 1 proton or the mass of 1 neutron. So they're incredibly small. And the other way that they're different from the other two is through the electron cloud. That's the region, the place that we tend to find our electrons. It's not that we tend to find them, it's that they are found in the electron cloud. They're not found in the nucleus. So I'm going to zoom in here so you can pause if you need to. Please keep in mind you can press pause. YouTube's amazing with pausing.